The third term is represented by D3. D3 is where you substitute the value 3 in place of the n everywhere that it appears. And then you're going to simplify that. And you get 3/5 for that answer. D4 is the fourth term. Substitute 4 in place of the n. And you get -4/7. And then finally, the fifth term, D5, replace the n with the value 5. And you get +5/9. Okay, so those are the first 5 terms of the sequence that you're told to write out. Similar type of example, write down the first 5 terms of the sequence. This time the sequence is called A. A sub n equals 3 to the n divided by n. And therefore the first term is going to be 3 to the first divided by 1, which is 3. The second term is going to be 3 squared divided by 2, which is 9/2. And the third term is going to be 3 to the third divided by 3, which is 27/3, which is 9. A4 is 3 to the fourth divided by 4, 81/4. And A5 is 3 to the fifth over 5, which, let's see, 81. 81 times 3, 243 divided by 5, I do believe. And those are the first 5 terms of the sequence A. Number 28, this given pattern continues. Write down the nth term of the sequence as suggested by the pattern. And so what you're trying to find now in this example is what this pattern is doing. This is the opposite of what we just got finished looking at. So instead of having the sequence pattern given to us and writing out the terms from that, we are given the first, 4 terms, and we have to figure out what the pattern is based on what we see, the similarities. How do you get from one term to the next? What seems to be happening? Now I'm noticing that each term seems to be consistent with a 1 on top. So I'm feeling like my sequence has a 1 on top of a fraction. Now what's going to go on the bottom? And so you're looking for how does the bottom part change from one term to the next? So in the first term, I have a 1 times 2. In the second term, I have a 2 times 3. Okay? In the next term, I have a 3 times 4, and then a 4 times 5, and so on and so forth. So in the first term, this is my first term, A1 is 1/1 times 2. In my first term, the first digit on the bottom was a 1, and the second digit was 1 bigger than that value. Let's see if that same pattern happens on the next term, which is 2 times 3 on the bottom. And so this is my second term. And the first value on the denominator is the same as the value of the term, okay, the order in line, the position in line. And then the next term is 1 bigger. So it looks like I'm going to be taking my whatever term value it is times 1 bigger than that. That looks to be like my formula for this particular sequence. And then you'd want to test your formula. Definitely want to test this out to make sure that it stays consistent. So for my third term, without looking at what it actually is, using my formula, this will be 1 divided by 3 times 3 plus 1 or 4. And that's consistent with the third term that you're given in your problem. And then just for fun, we'll try it the last time. The fourth term, according to your formula, says to take 1 divided by 4 times 1 bigger, which is 5, and that is consistent with the fourth term in your lineup. So you're pretty convinced, you're convinced now that you've got the correct formula for this particular sequence. 34 gives you a different obstacle to overcome. not only are my numbers changing, but they're changing signs, and they're alternating signs from positive to negative, positive to negative. And there is a trick that I needed to share with you on how to make your terms alternate in sign, plus minus, or minus plus minus plus. And that trick is by taking a base -1 to a power of n either +1 or n -1. It accomplishes the same thing. I usually just go with the plus version. And so what this is going to do on the first term, when n is equal to 1, if n is equal to 1, my first term will be -1 to the power 2, and that's a positive result. And your first term in your lineup is positive, so this is a good place for you to begin your sequence. Okay, that's going to make the signs alternate. So the second term would be when n equals 2, so -1 to the 2 plus 1, or -1 to the 3 power is going to give you a negative result. And so that would give you a negative second term. And then this pattern would continue, it would alternate in the sign. Now that takes care of the plus minus. How about going from 2, 4, 6, 8, 10? Okay, so 2 is accomplished by multiplying 2 times 1. 4 is accomplished with 2 times 2. Next, 6 is accomplished with 2 times 3. 8 is accomplished by multiplying 2 times 4. And 10 is 2 times 5. So I'm pretty consistent that I'm multiplying whichever term position I am by the constant 2. So I think it's going to be 2 times n to get my sequence to work out. So let's try it. Try it with the first term. Okay, the first term, according to my formula, would be -1 to the 1 plus 1 times 2 times 1, or just 2. -1 to the second power is positive. Positive 1 times 2 equals 2. The second term, a2, according to my formula, would be -1 to the power 2 plus 1 times 2 times 2, which would be -4, and that is consistent with the second term in your line. The third term, according to your formula that you think is right, we're going to do one more check, is -1 to the 3 plus 1 times 2 times 3, and that is going to give you a +6, which is what you were supposed to get. So until you're consistent and you are confident that you know that you have got the correct formula, then you should keep going to check it. And once you're convinced, you can stop. 38, a sequence is defined recursively. Write down the first 5 terms. Recursively is a new word for us. Recursively means that the next term is defined based on what you got for the previous term. All right, so you need to know the previous term in order to get the following term. That's what a recursive definition is doing for you. Okay, so you have a sequence whose formula recursively is given as an equals n minus an minus 1. And so a sub n minus 1, this is the notation for the previous term. All right, so you need to find the first term. Well, that's the beginning. You can't find anything before the first term. So the first term is your start. The second term is going to be based on what you got for the first term's answer. The third term would use your second term's answer. Your fourth term would use your third term's answer, and so on and so forth. And so if the first term is given as the answer is 1, the second term is going to be 2 minus a1, or 2 minus 1, or 1. The third term, do this a couple more times, the third term is going to be 3, because that's what the value of n is equal to, minus the previous term, which is a2. So this is 3 minus 1, which equals 2. The fourth term, let's go over here, the fourth term is 4 minus whatever I got for the third term. So this is 4 minus 2, and that equals 2. And the fifth term is 5, because that's the value of n, minus the previous term, a4. So 5 minus a4 I just got was equal to 2. So this answer is 3. And just so we understand, let's do one more for fun. So the sixth term would be 6 minus whatever I got for the fifth term, and that means 6 minus 3 equals 3. And so those are actually I did 6 terms for this particular sequence. The summation sign now is used for this particular sequence. You're going to hear two words in this chapter, and they have different meanings, although a lot of people use them interchangeably, even though they have separate meanings. We've been looking at sequences. Sequences. A sequence is a list of terms. That's a sequence, okay? With commas in between, right? We had a comma separating one term from the next. That's different from a series. A series is when you take a sequence and you add together all of the terms. So now that I see a summation sign in example 50, now I'm thinking of this as a series. This is now a series because your answer is going to be, if you know where to stop, you're going to get a number for your answer. Now in this particular case, we don't know where to stop. We're using the generic n stopping point. And so this time our sum is not going to look as nice. It's not going to be a number for an answer. If you knew where to stop, your answer would be a number. Okay, so just take my word for it. For this, you're going to want to pull out your formula sheet and start using some of the formulas that we've been acquiring for 11.1. Okay, so the sum as k goes from 1 to n is going to be, let's see if we can do this generally first. We might not need those formulas just yet, but it's going to be 2 times 1 plus 1. That's my first iteration. Next, that was where to start, right? Start with k equal to 1. The next counter number in line, the counting numbers go up by 1 each time, right? If you count from 1 to n, you would go 1, 2, 3, 4, 5. So the second iteration is going to be when k equals 2. With k equals 2, it looks like this. Next, k equals 3. Repeat this a third time. So 2 times 3 plus 1. Repeat it a fourth time. 2 times 4 plus 1. Repeat it a fifth time, a sixth time. You go on forever. You go on, put a plus sign right here. You go on until you stop. And you stop when you hit the value n. So that's going to be 2 times n plus 1. And so I am going to write this a little bit more concisely, right? I can work out each of these sets of parentheses into 3 plus 5 plus 7 plus 9 plus ... some stuff in the between, till you get to the end, which is 2n plus 1. And that's as far as we need to go. We don't need to simplify that any further. It says write out the sum. It doesn't say evaluate the sum. It just says write it out. And so we've expanded the sum into a series, which is a sequence whose terms have been added together. This is now a series.